Your warm-up should be done. You should be ready to check your answers. So here we go. On number 1, this is a difference of squares. You've got your x squared and the minus sign. In this case, these numbers were perfect. Remember, they don't necessarily have to be because we can use the square roots if we need to. But since they are, we can go ahead and know that 16x squared would be 4x and 4x. 49 would be 7 and 7. So when I put these into the two parentheses, we have 4x plus 7 and 4x minus 7. Now we're solving, so we need to set each of these equal to 0, the same number we've been working with. So we subtract 7 on both sides. 4x is equal to negative 7. Divide by 4. So x equals negative 7/4. Now you could go through and solve the second one, but remember with difference of squares we get one negative answer and one positive. So plus and minus 7/4. Moving on to question number 2. So this one, if we look at it, it's a difference of cubes. Difference, x cubed tells us it's cubes. So we start with the 27x cubed, and remember we need to break it down to the 3 factors that would multiply to it. So that would be 3x times 3x times 3x. 64 would be 4 times 4 times 4. So we get to the front of the line for the roller coaster. We have to decide, are we going to go in the line for the first car or for the rest of the roller coaster? One member from each group decides to go to the first car. The next best spot is right behind the first car. So these two group members go there. 3x times 3x makes 9x squared. The only other good place to ride a roller coaster is at the very end. So these two go there. 4 times 4 is 16. To get to that middle term that we need there, remember, after you get through the first hill, you go through the loop-de-loop. 3x times 4, well, that's 12x. And last but not least, we need to figure out our signs. So we use scream or puke. First one is the same. Well, it starts off as minus. Then the opposite of that, which would make it plus, and again, the last one is always plus. Now that we've factored it, we need to set them each equal to 0. So 3x minus 4 equals 0. 9x squared plus 12x plus 16 equals 0. In the first one, we add 4. 3x equals 4. Divide by 3. So x equals 4/3. The other one, we're going to use the quadratic formula for. So we label A, B, and C. So we plug them in, so we go x equals negative b. Well, since b is a positive 12, that makes it a negative 12. Plus or minus the square root of b squared minus 4 times a, which is 9, and then times c, which is 16. And that is all over 2 times a, so 2 times 9. Again, remember, you can use your calculators to figure out the inside part. So the middle part underneath the radical should come out to be a negative 432. So x equals negative 12 plus or minus the square root of negative 432 all over 2 times 9, which is 18. Well, we know that that negative inside the square root is going to make an I. So I can now write this as negative 12 plus or minus I times the square root of 432 all over 18. 432, if you type it in your calculator, it is not perfect. So we're going to do our chart. Well, it's even, so we know a 2 would go into it. So 432 divided by 2 gives us 216. Divide that by 2 gives us 108. Divide by 2 is 54. Divide by 2 is 27. So now we need to change to 3's. 27 divided by 3 is 9. Divide by 3, 3, 3, and 1. Remember, we're looking for pairs. So here's a pair of 2's, 2's, and 3's. Well, 2 times 2 times 3, that's going to be 12 on the outside. So I have negative 12 plus or minus 12i square root of 3 all over 18. Last thing is we check the 3 outside numbers, if they can be divided by something. They're all divisible by 6. Well, negative 12 divided by 6 is negative 2. Plus or minus 12 again divided by 6 is 2, so 2i square root of 3. And then 18 divided by 6 is 3. So here was 1, 0, or solution. Here are the other solutions. Here's your homework from last night. The first 3 were your difference of squares. And they all came out nice and pretty. So 2 answers, one a positive, one a negative of the same answer. So you can check and pause as you need to. 23 and 24 were your sums and differences of cubes. These probably took a little bit longer. Remember, the first one you just solve for x. The second one you do have to use the quadratic formula. Number 23, you've got negative 2, and then 1 plus or minus I square root of 3. 24, the first answer was 2/3, and then the final answer for the last one was negative 1 plus or minus I square root of 3 over 3. Pause as you need to look over the work. We have our last type of polynomial that we're going to be solving, and then of course that means factoring first. Now with these, our highest degree is going to be an x to the 4th, and we're going to have x to the 4th, x squared, and then nothing here. So it needs to be set up this way: x to the 4th, x squared, and then no x's. The first thing we're going to do is we're going to factor using x squared instead of x. And we're doing this because we have to get to an x to the 4th and not an x squared. So if you have x squared times x squared, then you get x to the 4th. We're going to cross out the next line. Once you've factored it, we're going to set each factor equal to, I'm sure you can guess what number we're setting them equal to, which is of course 0. So we first start with the Santa hat method, just like we have been. So I'm looking for factors of 1, because that's our a value, times negative 4, which is negative 4, and they have to add up to negative 3. Well, the factors of a negative 4 that would add up to negative 3 would be negative 4 times 1. So we'll put these directly into parentheses. So we start our 2 parentheses, we do x squared instead of x, and then one has the minus 4, and one has the plus 1 for the positive 1. So now we set each of these equal to 0. And we start solving for x. So the first one to solve for x, we would add 4. So x squared is equal to 4. Now, in order to isolate x, we always do the opposite. The opposite of squaring would be the square root. The one thing you have to keep in mind when you have a square root of 4, and we talked about this earlier, you could have 2 times 2 is 4, or negative 2 times negative 2 is 4. So you're going to get two answers. So we have x equals plus or minus 2. So whenever you personally insert the square root into the problem, you have a positive answer and a negative. On the second equation, we're going to subtract 1. So x squared equals negative 1. And then again, the opposite of a square is to take the square root. Now, we know we're going to have a positive and a negative. Well, the square root of negative 1, the fact it's a negative means we're going to have the letter I. Square root of 1 is just 1, so it's plus or minus 1i, which is the same thing as I. So the zeros for this polynomial are plus and minus 2 and plus and minus I. We've got one more to try together here. Now if you look at this one, we saw these in earlier solving problems, and hopefully you can see what's wrong with this problem. One side has to equal either a function, f of x or y, or if it's a number, it has to equal 0. So since this does not equal 0, it equals negative 16, we need to move this over in order to solve this. So to move a negative 16 over, we're going to add 16. Now I check the left side and there's no other numbers to add 16 to, because you can't add 16 to x to the 4th or an x squared because they're not like terms. So we want to write it at the end of that trinomial. So x to the 4th minus 8x squared plus 16 is equal to 0. So now we use our Santa hat. So we're going to go 1 times 16, which is 16. And we need factors of that add up to your middle term, your negative 8. Well, to multiply to a positive but add to a negative means we have to have two negatives. And the factors of 16 would be negative 4 and negative 4. So we do our two parentheses, x squared minus 4 and x squared minus 4. Now, since each parenthesis is the same, when we set them equal to 0, we don't actually have to solve both of them. So we would add 4, x squared equals 4. Remember, if it's an x squared, the opposite of squaring something is the square root. So we're going to square root both sides. And the other detail to remember is that when you have a square root, you have to have both a plus and a minus. So we have x equals a positive and a negative 2. Now, since that's the exact same answer we would get if we were to solve this one, we don't have to solve it, so our zeros are plus and minus 2. Now, because that does appear twice in the parentheses, it might be good to remind yourself that it does have a multiplicity of 2. Wasn't asked for this, but it's always good to remember all of our details we've had so far. We're going to wrap class up with the U-try problem using the steps that we just did. So go ahead, try the problem, check with the neighbor at the end or as you go through, and then unpause this when you're ready to check your answer. Well, the first thing with this problem is it's not equal to 0, so we have to take care of that first. So since it's a positive 18, we're going to subtract 18 to both sides. So we have x to the 4th plus 7x squared minus 18 equals 0. We then use our Santa hat method. So it's 1 times negative 18. And we need that to add up to 7. So one number has to be negative, one has to be positive. The 7 is positive, so the bigger one needs to be positive. And we're looking at 9 and negative 2. In your parentheses, since it's an x to the 4th, you should have separated to x squared plus 9 and x squared minus 2. Remember, it doesn't matter if you were to have put the minus 2 in the first parenthesis and then the plus 9 in the second. Both ways is fine. So we set each of these equal to 0. The first equation, we're going to subtract 9. So if x squared equals negative 9, when I take the square root of this one, because it's a negative, we know we're going to have the letter I. And since 9 is perfect, it becomes plus or minus 3i. The second equation we're going to add to. X squared equals 2. Well, x squared, we have to take the square root of it. We insert our plus and minus. Now 2, can I take the square root of it? No, it would give us a decimal. If I were to put it in the chart, we wouldn't have any pairs because the only thing you can divide 2 by is 2. So we just leave it as the square root of 2. So your zeros for this problem are plus and minus 3i and plus and minus the square root of 2.